Bismillahirrahmanirrahim. Assalamu alaikum. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Rabbi zidni ilma. Children, today we are going to study the topic software. But before we move on to this one, let's talk about what do you think is a computer program? Yes, what comes to your mind when you hear the term program or programming or computer program? Okay, now please pour in your ideas, pour in your answers. Okay. Program is a set of instructions. Okay, correct. A computer program is considered to be a set of instructions that is meant to perform a specific task. Perfect. Now, if you think, is it linked with some sort of specified task, or any task that comes to your mind will be a computer program? What do you think? Every task that we are doing with the help of a computer is going to be a computer program. Okay, now let's see what a computer program actually is. First thing is, what we need to know is a computer program tells a computer what to do, how to do, and when to do. Now, this is actually going to be an instruction, definitely whatever some students have told me. It will be telling the computer what to do, kya karna hai, how to do, kis tarah se karna hai, and when to do also is going to be judged by the computer program. When the program will be active, when the program will become active, that will also be handled by the computer program. Now, what we talk about is the computer that we use, the computer that we program on is performing many different tasks. Like think, what can you do on a computer? Like you are using a computer right now, or maybe you are using a laptop right now. So just think, what actions can you perform on your computer? Please, very quick answers I want from your end. Okay, you can type. Okay, now what else you can do? You actually watch movies, you play games. Your father is using a computer for his own office tasks. It means, are you people using separate computers for different tasks, or are you people using the same type of computer or the same computer for all these tasks? Is it the same? Yes. It means that a computer can be used to stream videos. I mean, I was expecting this answer to come from in the beginning, that mainly we are using a computer for entertainment and mainly for streaming videos or listening to the songs, writing reports, provide weather forecasts, and many, many other jobs. You can see some of the tasks are specialized ones which may not be used by us, but these are certain things that are designed, and they are used by the programmers, and they are actually designed by the programmers, used by us, and they are like special tasks also, and they are also computer programs. So what a computer program actually is, simplest definition, as was said in the beginning, a computer program is a set of instructions that are going to be executed in a sequence to get some task done, and that program will be any type, like can be for streaming of videos, watching anything, watching a match, or whatever you are doing. These all tasks are done by a computer program. Let's move on to the next thing. Now, if I talk about languages, what comes to your mind when you hear the term languages? And why do we need language? Or which languages can we speak? Like, for example, language is needed to communicate. Definitely, if I am speaking to you, I need some language. Like if I was standing in front of you in the class, I'll be using some other language, maybe the sign language, maybe my gestures. But when I am sitting here at my home and you are sitting at your home, and we are in the learning process, so I'm using some language, and that is maybe English or Urdu. Like I have spoken a few statements in Urdu. So these are all languages, and we all need languages to communicate. Now, be very clear, we all need languages. Even a child also uses his language by crying. That is also his language. That is how he actually expresses whatever he wants. So same case is applicable with the computer. We actually talk about 3 languages. The first one is high-level language. The second one is low-level language. And the third one is machine language. So we are going to study these languages separately, one by one. Be very cautious, make your notes, and remember them. This is a very important topic as far as the O-level syllabus is concerned. Very first thing, what a high-level language is. It enables a programmer, and who a programmer is, I hope that we all know, the one who designs a computer program. And this high-level language biggest advantage is it is enabling the programmer to focus on the problem, the actual problem to be solved. By the way, I'm actually recalling the term problem. We have done it. Does problem mean Kashmir problem? Does problem mean something that is dealing with a bigger thing, or a problem means any simple task that is given to me? So you can see it is enabling a programmer to focus on the problem to be solved and require no knowledge of the hardware. Even if you have no knowledge of the internal structure of the hardware, still you will be able to design a program in high-level languages. And believe in me, since the advent of high-level languages, computer science has actually been very much, can say, in demand. People are using it, and people are, can say, it has become more popular. Like if I talk about a very long time back when the computers started, I hope that we have studied it in your hardware chapter, that in the beginning, all the programming was done in machine language or zeros and ones. But then slowly and gradually, there was a little shift. It was low-level language, and then it was high-level language. And these high-level languages have actually changed the whole scenario. People are using them. They are becoming popular, and even the children are learning them. Okay? So in it, the biggest advantage is it is going to focus on the actual problem to be solved and require no knowledge of the hardware at all. You can work on it without the knowledge of the hardware, and still you will be quite successful in your work. Many programming languages are portable. Now, what does portability mean? It means that design for one can work on different types of computer. Like if I have designed a computer program in high-level language for one architecture, for one type of machine, that same high-level language program can be used on some other machine. There will be no need to change any instructions. It will be used in the same manner because high-level languages are portable. They can be used on the same language, and the same language program can be used on different types of computer system, which is making it very, very effective, very, very popular. And the second biggest advantage is it is portable. Now, why is it popular? Because it is using the instructions, it is using the commands that are very closer to the English language. And that is why they are becoming very popular, because like once you start using the languages, by the way, can we get the answers for the high-level languages if you can recall? You may have heard about different languages. Like I'm expecting the answers to come from your end very quickly. Any language that you are aware of, which is the most popular language, which is learned by the students nowadays, and they are talking about it all the time. If you have, most of you must have heard about Python. So this is a high-level language. You may have heard of BASIC or Visual Basic or C or C++, or even some of you may have heard about COBOL. They all are high-level languages because the instructions, the commands that are being used in these languages are closer to English. So since a person can know, like for example, I'm just using an example right now, like for example, input. Now, if you pay attention to the word input, you can think yourself that this is meant to take input. If I say print, again, very simple command that is used in Python to print something. So these are simple commands which are very much similar to the English and language, and that is why this language is becoming very popular. High-level languages are gaining more popularity, you can say, are used by people because of these advantages. As far as writing is concerned, writing a high-level language program is very easy because it is written in a very short span of time. And debugged means finding out the errors. It is written in a smaller time, in a very shorter time, and besides this, it is also debugged. It is very easy to find out errors, and sometimes the errors are also given, sometimes the translators are also giving us the hint that what are the probable mistakes, and we can correct them so easily as far as high-level languages are concerned. Any ambiguity, any questions regarding these high-level languages before I move on to the next one? Okay, now you can actually note down the high-level languages that are popular, although you should be knowing them for your own benefit. Like I talked about C, C++, Python, Basic, Visual Basic, they all are the high-level languages. May I move ahead? Okay, the next one is low-level languages. Now, what are low-level languages? Why are they low-level? First thing that you need to know is they're not low-level for a computer. They are low-level or difficult for a human. Why? Let's see. They are linked with a specific hardware or specific architecture. Now, architecture, you have studied a little bit. You are aware of the architecture, von Neumann architecture. You have heard this term before. So every single computer, like we are using Intel or maybe Intel compatibles, and we have talked about different other architectures. So they all are using a specific instruction set. As far as low-level languages are concerned, they are linked with that particular architecture. They are linked with that particular hardware. And that is why they are not portable. This is one thing that you need to know when we talk about high-level languages. High-level languages are portable, while low-level languages are not portable. Designed for one can work on that one only. It means if I have to make a program for a new, I have to work on a new computer system, on a new architecture, I have to design the program for that architecture once again, because the low-level languages design programs are not portable. They are designed for that particular architecture only. Now, as far as low-level languages are concerned, some people call them that they are similar to the machine code, because they can refer to the machine code. And if you recall the term machine code that you have studied earlier, it is the binary instructions, the zeros and ones, which is readily understood by the computer because that is computer's own language. It does not need any sort of translation because machine code is computer's own language. वो उसको फौरन समझ आती है. It does not need any sort of translation at all. And it refers to assembly language, and definitely that needs to be translated into machine code. A little bit of assembly you need to know as far as the question pattern is concerned. Like once I'll show you some different examples, you'll be able to comprehend very easily that this is an assembly language code and this is a high level language code and this is definitely a machine code, which is easiest to comprehend because machine code is just a combination of zeros and ones. Now, this is something that you all must have heard. Machine code. Machine code is binary code. I can see this is the example that is mentioned. The structure that you can see here, the binary code is zeros and ones, and hexadecimal. By the way, if you recall hexadecimal, that is also something that computers understand, or we can work on hexadecimal values also, because a computer can work on them also easily. Programmers do not usually write down the code in machine code because it is very difficult to write. It is very difficult to understand. Now, if I talk about before the von Neumann model was von Neumann architecture was proposed by John von Neumann, all the programming was done in zeros and ones, and it was too difficult for the people to comprehend, to remember, to write down the code. It took a lot of time also, but still, that was popular for a reason, that it was readily understood by the computer. There was no need for any sort of translation. It can be complicated to manage data manipulation and storage. Now, it was very difficult. That's what I told you. People who were designing the program in machine code, they were the ones who had to be extra cautious because even a mistake of a 0 or a 1 was a disaster. So they had to be very, very cautious whenever they were writing down the program using machine code. Any questions? Like we have covered high-level language, we talked about low-level language, and we linked low-level language with assembly code and the machine code. Any questions, any ambiguity? Okay, now I'm waiting for your questions. Any questions? Should I move ahead? Okay, that's wonderful. Thank you. Now, this is just an example, as I discussed right now, that it was this was a program that was written to add 2 numbers, and this is shown in both your binary and hexadecimal, and you can see these both are a little difficult for the humans to comprehend as compared to the computer. Easy for computer, difficult for humans. Now, assembly language. Although assembly language, like if I remember, we talked about that. Like, let me tell you one thing. Assembly language program will be definitely learned by you people, inshallah, when you move on to the A levels. But right now, what you need to know is very few programmers are still writing programs in assembly language, and the ones who are doing it, why are they doing it? Are they intelligent? What comes to your mind? Yes, they are very intelligent. That's why they are writing program in assembly. They need to show themselves to be extraordinary, can say extraordinary genius. Is that the reason? Okay, now that may be in your mind, but let's see what the actual reasons are. The first thing which is making assembly language programs still popular is they make use of special hardware. Like the ones who are designing programs in assembly language, they can actually work on the hardware, like different types of registers, different types of machine instructions can be used whenever you're working on assembly language. Make use of special machine-dependent instructions. Like machine-dependent means, as I said in the beginning, low-level languages are portable or non-portable. Yes, very quick. Which one is portable? Low-level or high-level? Yes, Ali? Okay. Ahmed? That's wonderful. High-level languages are portable and low-level languages are not portable. So you can see in low-level language or in assembly language, they are making use of special machine-dependent instructions. Means designed for one can work on that only, not on any other one. And that is why assembly language programs are still being used. Most important is writing program in assembly language means it does not take up much space in the primary memory. By the way, can we recall the term primary memory? You've studied it. Okay, which words strike your mind when you hear the term primary memory? That's great. ROM and RAM. Fine, that's wonderful. Now, if I write on the code that is written in assembly language, if I write on the program in assembly language, it is not going to take up much space in the primary memory, and that is a very big advantage. To write code that performs a task very quickly. So the biggest advantage is still the people are programming in assembly for the reason that they are using codes that are going to perform the task very quickly. And this is making them very popular. Now, there's a small program just to make you comprehend that this program is meant to add two numbers together. And this program consists of 3 statements only. That's so wonderful. Now, LDA, ADD, STO. These are the 3 statements that are in assembly language, that are used in assembly language, and which you are going to study, inshallah, in A levels. And what are they for? LDA is doing what? LDA is loading the value of the variable, and I hope that you all know what variable is. Yes, very quick response I want from your end. What is a variable? Okay, that's wonderful. Okay. A place in the memory, a data stored that stores changing values. That's wonderful. So you can see LDA is an instruction that is used in assembly, and that is loading the value of the variable. And in this case, what you can see here is LDA, after LDA it's written first. And the space is only given to make you comprehend that there is, like just to make it very clear. Otherwise, it's not the norm. So LDA first means it is going to load the value of the variable, whatever value has been put by the user into the variable, in this case space first, and that value will be moved to the accumulator. By the way, who can recall the term accumulator? What is an accumulator? We have talked about accumulator. If you recall CIR, if you can recall the other registers, we have talked about the registers and buses. So accumulator is actually a register that is normally meant to store the data that is being processed. After processing, the data is being stored there. To be processed also, it's stored in accumulator. But for you people, what you need to know is accumulator is a register that stores the result of after the processing is being done. Now, another command or instruction that we can see is add. and again add. It adds, and again, although it is in assembly, but still it is something similar to what you normally come across. Like add means add. What is it doing? Adds values of the variable, in this case second, to the value stored in the accumulator. Assume first was holding 5 and second was holding 3. So what will add do? Add, now LDA will store the value 5 in the variable in first, and as far as add is concerned, the next variable is second, and add will actually add up the two values from the accumulator. 5 and 3 will be added, and the value will be stored back in the accumulator. So now let's see that what is add doing. It is adding the values of the variable. The two variables, the first one is an accumulator and the second one is the value that is being stored right now in the variable second. And the third instruction, as you can see, is STO. And that is replacing the value of the variable, in this case sum, by the value stored in the accumulator. So 5 plus 3 was 8. So STO will store the result of this processing in the variable sum. I hope that this is very much clear to all of us. Any ambiguity, any questions? So please, you may ask. Any questions regarding the topics that we have learned till now? So please do ask. Okay, I'm showing this screen. I'm giving you 5 minutes to very quickly go through this whole screen, which is dealing with the advantages and disadvantages of high level and low level language, and then we'll talk about it. Fine? Very quick reading for 5 minutes. I hope that you have read the advantages and disadvantages, and you have compared it with what you have noted down right now or what you have seen from the book. So they are similar, but here I've just shown you so that you can actually just make a note for your own self that this is how you will know, you should know the advantages and the disadvantages. Definitely, everything has advantage, everything has disadvantage. We are not going to say, okay, something is only containing the advantages, no disadvantages are there. So you can see the advantages are mentioned here, the disadvantages are mentioned here for both the levels, and you need to know because a question can come in the paper that asks you to compare the two languages, the two levels, and write the advantages or the disadvantages. But be very clear that whatever you are writing should be very clearly written so that you are able to score. If they say two advantages, pick up any two advantages, and then if they say disadvantages, pick up any two disadvantages, and in this manner you can easily score very easily. You can very easily score, but be cautious. If they say differentiate, then you have to mention differentiate in this manner, like for example, high level language is portable. I'm just giving an example. High level language is portable while low level language is not portable. So in this manner, you will be able to gain 1 mark. Be very cautious. You need to know the art of scoring, and scoring is very easy if you learn these simple things. I move ahead. I hope that no questions regarding this topic, so I'm moving ahead with the next term, and that is a translator. By the way, if you talk about the term translator, what comes to your mind and why do we need? Like, assume that I went to maybe I have been to China and I don't know Chinese at all. I met a person who is not ready to speak, although maybe he knows English, but he's not ready to speak to me in English. What do I need then? I need the services of a translator. And what will that translator do? What is the job of the translator? Making my language understandable to the Chinese, and whatever Chinese is speaking, make it understandable to me. Same case goes here. I don't understand computer language, which is binary, and computers do not understand what I write in English, like instructions, which is high level. What I need in between is the job of a translator. So let's see what translators are for and which translators are used by the program. Programs written by humans are understood by the computer programmers, definitely because they are written in such a manner which are written by the programmers easily. Like we have talked about, the high level language is easiest for the programmer. That is why they are gaining popularity. They are used by the programmers, although some people still program using low level language. In order to be used by computer programs, need to be translated into the binary instructions. Remember, the computer understands only the binary instructions, only the machine code. It does not understand at all if you write down a program in low level, or if you write the program in high level. It only understands the binary. It only understands the machine code. It only understands the zeros and ones. That is the only thing a computer comprehends. I hope that it's very much clear that whatever we write is not understood by the computer, and we need a translator for making it understand. And why do we need this language? Why not we program in machine code? I think it is very much understandable, because if I talk about us also, if we say, okay, my name is Sadaf, for example, if I say I'm going to store the binary for Sadaf, SADAF, and I'll be actually writing down not my name as SADF, I'll be writing down the binary. Oh, that will be too difficult for me. So that is why we need a translator to make the program understandable to the computer and making it easy for the humans also. And it is very difficult for the humans to write down zeros and ones. This is what we have been discussing since the beginning. And that is why the von Neumann model was being introduced, to make the life easy for the programmers or for the people. The very first the very first translator that we need to know is a compiler. The second one is an interpreter, and the third one is an assembler. What is a compiler? What are compilers? First thing, compiler is a computer program. Remember, it's a computer program, and that translates an entire program written in a high-level language into machine code all in one go. And it can be used by the computer to perform a required task. I'll give you an example just to make the concept clearer. Assume that I have a child, I have a student, and I have two students. The first one is given a paragraph of 5 sentences, and second one is also given a paragraph of five sentences. What is the first student doing? He's translating the whole paragraph and showing me the whole translated passage. On the contrary, the second one is translating each line separately and is showing me the result. So the first one is working like a compiler. As you can see, a compiler is a computer program that translates an entire program written in high-level language into machine code in one go. The way the first student did the translation all in one go. Similarly, translators, compilers translate all in one go. And they produce the executable file. And you can see they produce an exe file, and that exe file can be used repeatedly without the process of recompilation. Because once you have compiled the program, the same program can be used repeatedly. We don't have to go for the recompilation until and unless a change is made, and then I have to recompile. Otherwise, if there is no change, then that program can be used again and again by us because it does not need any sort of recompilation. One more thing is compilers create executable files. Exe files, in short, we call them exe files, but they are creating the binary files or the exe files which are used repeatedly without the process of recompilation. I have no questions. But one thing, if there is any problem encountered by the compiler, it will not move ahead until and unless that error is removed, that because it is going to create an error report, and that error report will be containing all the errors. And once all the errors are being removed, only then the compiler is going to create the exe file. By the way, I'd like to share one instance of my own learning. Like I remember I was actually learning a program development in C, and I had made a mistake in the first line. I forgot to put I made a mistake. Believe in me, my program showed me so many errors, and I was actually very confused कि what has gone wrong, अब क्या हो गया? Well, definitely हम भी परेशान फौरन हो गए कि अब क्या हो गया है? So what actually was the problem is that there was one mistake in the first line, and once I corrected that error, the whole process was redone and the program was compiled. So this is what, if an error is detected, even if one error is detected by the compiler, it will not create the exe file at all. It will prompt me to remove the error. And once the error is removed, all the errors are removed, only then the compiler is going to create the exe file. Only then the compiler will actually make a program for me that can work on different computers, that can work actually without recompilation. Okay, are you clear? Now, is the turn of interpreter. As the example that I quoted right now of my student, what he did was, the second student was translating each line. He translated line number 1, came to me, and then moved back, then translated the second line, and then translated the third line. In this manner, he came to me 5 times after translating each and every line. He is working like an interpreter. A computer program that reads a statement from a program written in a high-level language, translates it, performs the action specified, and then does the same with the next statement. Just like the second student, excuse me, it's going to translate one line at a time, one statement at a time. It will pick up statement 1, like the second student. He picked up a sentence. So similarly, interpreter will pick up one statement in a high-level language program, translates it, performs the action, and then move back. And then performs the action on the second line, translates it, performs the action. Then picks up the third line, translates it, performs the action. In this manner, the whole program will be interpreted line by line, picking up the said statement, translating it, and executing it. On the contrary, the compiler was translating the whole program in one go. And if there's an error in the statement, then execution stops and an error message is output, sometimes with suggested correction. Now, this is what is happening with an interpreter. In case it encounters a problem, like I said in the beginning, translating, picking up statement, translating, executing. But in case, again, I've made a mistake, maybe a mistake of spelling. So it will definitely be going to show me the error in the statement, and the program will stop, and the program will not work until and unless that problem is removed, and the error message will be shown to me. And once the error is removed, only then the work will be done in continuity. One problem, I'm not going to call it a problem, but this is actually a sort of can say a comparison between interpreter and compiler is an interpreted program is always needing the interpreting repeatedly. Like I have interpreted a program once. Since no compilation is being done, no exe file is being created. So if I am running the program second time, the interpreter will work in the same manner from line 1, statement 1 till the last line. It will keep on picking up the statements, interpreting them, and executing them. So that is what is the difference between a compiler and an interpreter. A program needs to be interpreted again and again each time it is run. I hope that there is no ambiguity. And now I'm moving on to the last one, and that is assembler. Just one thing that you need to remember is assembler. Okay, now I have learned it that when I was a student like you. I linked assembler with, okay, that's wonderful, Ali. You have picked up assembler was linked with assembly. So since assembly is a low-level language program, that's why I remembered, I learned it this way, that assembler is a translator used for low-level language, or in other words, assembly language programs. Let's see. A computer program that translates a program written in assembly into machine code so that it can be directly used by a computer to perform a required task. Simplest definition that you need to know is assembler is a computer program that is needed to translate a program written in assembly, and that program will be used by the computer for performing a specific task. Once a program is assembled, the machine code will be used again and again to perform the same task without reassembly. Now, this is something which is really very beneficial. Once we have used assembler to translate the program, the same program will be used repeatedly without reassembly. By the way, which translator is doing something similar? Yes. Was it a compiler? Excuse me. Was it compiler or was it interpreter? That's wonderful, Ahmad. It was the compiler. So you can see that compiler and assembler have one thing in common that you can see right now, and that is they both are creating the machine code that can be used repeatedly without the process of recompilation, without the process of reassembly. Fine. Any questions? Now, once we are done with all these translators, we are learning these translators at a glance. Now, I'll tell you how the question can be framed from this one. But just let me tell you one thing. I have learned it that way. I've actually made a shortcut to remember the translators. I made a shortcut CIA. C for compiler, I for interpreter, and A for assembler. So in this manner, CIA, I hope that none of us is going to forget that this acronym, this abbreviation. So compiler, interpreter, and assembler, we have made a shortcut. Compiler C, interpreter I, and A is for assembler. By the way, just go through it quickly, and then I'm going to ask you a few questions, and that can be framed for your own benefit. You can learn it for the purpose of exam. Now, let me actually read very quickly. Compiler, translate out. Just recall how many of the lines you already are aware of. Translator is a compiler. Translates a high-level language program. Now, be clear. The word program is very important. Translates a high-level language program into machine code. An executable file of machine code is produced. One high-level language statement can be translated into several machine code instructions. That is very interesting, that if you use the word, the high-level language statement like print, so that one high-level language print statement is translated into several machine code instructions. Compile programs are run without the compiler. Again, the same thing. We don't need a compiler once the compile programs are being executable files are being run. A compile program is usually distributed for general use. Like normally, the ones that we use normally, like maybe Word, or Excel or PowerPoint or all these programs or all these games, they are either compiled or assembled. Interpreter executes a high-level language program one statement at a time. No executable file of machine code is produced. The second point is no exe file is produced. Now, third point is one high-level language program statement may require several machine code instructions to be executed. The fourth point is interpreted programs cannot be run without the interpreter, the same as we discussed right now. An interpreter is often used when a program is being developed. Now, this is very interesting that you need to know. Normally, the people who are designing the program, they are using an interpreter so that they can see what the errors are rather than going for the compilation, because they work on small parts. So they actually use interpreter to work on those small parts of the program or modules. And once they are happy with the whole working, then they can use a compiler later. But right now, we are working on interpreter. And then assembler, the last one. It translates a low-level assembly. It translates a low-level assembly language program. Now, be cautious about the term program. That is very important. If you missed the word program in your answer, that will not be treated as a correct answer, because all these translators compile the programs that you write in your high level or your low level. An executable file of machine code is produced by the assembler. One low-level language statement is usually translated into one machine code instruction. By the way, who can recall the low-level language instruction that we have just talked about? Very quick responses. We have talked about 3 instructions. Can you recall? Okay, now just recall anyone. Okay. Add, fine. But if you can recall, the second one was LDA. Second one was ADD, add, and the third one was STO. Now, we'll talk about the questions later, but right now we are just concentrating on that one statement is like, if I say add, and if I say maybe add second, so that one low-level language statement was needing only one machine code instruction. On the contrary, if I was using high-level language, that one high-level language command or statement that I'm writing will be needing many machine code instructions. Just remember which one is going to be easier definitely for a computer. If you talk about this one, definitely low-level language will be closer to the computer as compared to the high-level language. Assembled language programs are used without the assembler, and assembled program is distributed for general use. I think we all are clear about these. I've read it for you. Now, question part. What can they ask you? They may ask you that talk about the similarities between compiler and interpreter. So which similarities can you find out from these two first columns? Very quick responses. Okay, very good. The first point, that is high-level language state program is converted into machine code. That is the similarity between the compiler and the interpreter. Is there any other similarity that you can figure out? Okay, that's wonderful. The third point, one high-level language statement is translated into several machine code instructions. That is the second similarity. So you can actually note down that there are 2 similarities between compiler and interpreter, the first and the third one. And the second, fourth, and fifth are the differences. So you can be asked that what is the similarity between compiler or interpreter, and they can ask you even what is the difference, and they do ask differences between compilers and interpreters. So follow the same as I talked about. When they talk about differences, you will mention, like for example, one difference I'm telling you right now, difference will be an executable file of machine code is produced in compiler, while in interpreter, no executable file of machine code is produced. That will give you 1 mark. You need to mention for one thing for compiler and second thing for interpreter, and you can say connect them with the word while, and only then your answer will be considered as a complete answer for 1 mark. Same case, you can talk about any other point, like if they ask you about 2 differences or 3 differences, you can just do in the same manner. Any ambiguity, any questions? Okay, that's wonderful. Now, a question can be raised. Is there any similarity that you can figure out between a compiler or an assembler? Okay, that's great. Point number 2, and point number 4, and point number 5. That's great. So these points are the similarities. As you can see, the compiler and an assembler, they both are creating exe file, which is going to be used. They both are run without the compiler or the assembler, and they both are distributed for general use. Okay. And as far as differences are concerned, it's very obvious. Compiler, which is abbreviated as C for us, just for our sake, is a high-level language translator, while assembler is a low-level language translator. Any ambiguities, any questions before I proceed? Now, advantages and disadvantages, you can see easier and quicker to debug and test programs during development, as I said. Easier to edit programs during development is the advantage of interpreter. And programs cannot be done without the interpreter. Programs can take longer to execute. This is going to be the disadvantage that you can see here is the for interpreter. As far as compiler is concerned, a compiled program can be stored ready for use. You can use it as soon as you have compiled it. A compiled program can be executed without the compiler. You don't need a compiler at all. You can work without the compiler. You don't need C. You don't need any sort of compilation once the exe file is being produced. A compiled program takes up less space in the memory when it is executed. A compiled program is executed in a shorter time. On the contrary, it takes longer time to write, test, and debug programs during development. And that, as I shared my fear with you, believe in me, when I was designing the first program in C, I was actually thinking that how will I be able to manage, but alhamdulillah, that is really a very great journey regarding the different translators that we have worked with. Any questions? Okay. Jazakallah khairan kasira for being a part of this whole journey. Allah Ta'ala may bless you. But be prepared. Inshallah, I'll be sharing the next video that will be dealing with IDE and the errors that are normally debugged, that they encounter. So just stay tuned, like my channel, subscribe my channel, and share it with your friends and family so that they are also going to benefit from my videos. Allah Hafiz. Jazakallahu khairan kasira.